End use of rainwater is our next lesson, and I want to focus on these kind of final elements right before we use the water in the house that again contribute to the overall quality of the water and are part of the rainwater treatment train. So the first one, yeah, would be the hot water supply.
So it's interesting that we have hot water listed at the end use of rainwater, but the hot water service or system is actually one of the end uses of water and rainwater if your house is off grid. So the interaction with hot water is an end use, and my research group in Australia have conducted years of research into this. In fact, we discovered new ground, in fact, that domestic scale hot water systems actually dramatically improve rainwater quality, and some textbooks have now been rewritten because of those discoveries. In the past, the food industry heat death of microorganisms was confused with what might happen in rainwater, when in fact no one had ever tested rainwater. So my research group I discovered this concept in my PhD, that sort of domestic temperature hot water systems actually dramatically reduce the microbes in rainwater. And then I had a PhD student called Anthony Spinks who did his entire PhD on the rainwater treatment train and heat death of bacteria in domestic hot water systems. And here's a table. We've
Okay.
got a number that we can show people in the course. So this table actually looks at field studies, and you can see there's a fairly large number of samples there. And in this case, we tested all coliforms, E. coli, and heterotrophic plate counts, HPC. And what HPC stands for is all carbon-fixing bacteria. So some counts of that are not that worrying because there's a range of natural bacteria in rainwater harvesting systems that are actually not harmful to you and actually quite good for you in some cases. So, and coliforms are quite misleading in rainwater harvesting systems because the indicators in coliform tests are actually environmental bacteria. So it's a bit interesting. And we now know E. coli can be an indicator of fecal contamination of water. But in the environment, there are over 32 species of E. coli that are naturally occurring and nothing to do with contamination. So we always need to read these tests with care. So what this is showing us is hot water systems set at less than 50 degrees Celsius in homes had quite low mean values of coliforms and E. coli. Note the E. coli result, 0.13 of a colony forming unit. So 1/10 of one unit was the mean result. And the maximum result was only 0.65 of a colony forming unit. So basically, even set at around 50 degrees, the hot water system was eliminating majority of the bacteria that are indicators of what we might be concerned with. When we step up to between 50 and 59 degrees, you can actually see there that the results for coliforms and E. coli have changed dramatically, and also from the heterotrophic plate counts, which is all bacteria. In guidelines in some countries, in rainwater, they're looking at a heterotrophic plate count of less than 500 to give you an idea of what sort of measure we might be looking for. So it's a pretty good result. And when we get down to above 60 degrees, you can see there's almost nothing in the of those indicators in the rainwater. So domestic hot water services systems are very good at eliminating bacteria from water. However, having gone through all this work, we then realised why a lot of plumbing standards in Australia and around the world require domestic hot water systems to be set at greater than 60 degrees to eliminate bacteria from utility water systems, um, because um, between the treatment plant and the house, there's all sorts of opportunities for different types of bacteria to be engaged in mains water as well. And not all bacteria is taken out by chlorine. In particular, concerns about Legionella, which are associated with hospital um, warm water systems, mostly not rainwater harvesting, has led to these almost worldwide hot water standards above 60 degrees. We've now learnt that that's not necessary, but if you look at your plumbing code and around hot water temperatures, you'll find this 60 degrees and you'll wonder why. That's why.
Just that point you said, we've now learned that this is not necessary for. I mean, you just made a really good point here of how this is actually quite effective at eliminating these parameters. So help me understand what you mean by we've now learned it's not quite necessary.
We find that it's not just purely heat that kills bacteria in domestic hot water systems. It's a process called tyndalization, which is the change in temperature. So it's called heat shock. So
Mm.
so if the rainwater stored in your rainwater tank and say it's 10, 15 degrees, maybe 20 degrees in summer here, and then all of a sudden it's heated to 50 degrees, that sudden change in temperature creates heat shock proteins, and your bacteria dies from that. And the changes in temperature, say in your hot water service, small changes, 1 or 2 degrees up or down as it tops up and heats up again, if you've got a storage hot water service, is a process of pure tyndalization. So the really stable soil bacteria, environmental bacteria that is largely harmless to us, it's more resistant to dying, but we're not that worried about it. But the closer a bacteria is to being a pathogen, the more mutated it is and more fragile it is, and the more it doesn't like changes of temperature. For example, Legionella hates changes of temperatures, and a lot of the bacteria that might come from birds, like Salmonella, for
Campari.
example, they're very fragile to changes of temperatures, quite vulnerable to that. And Campylobacter is another one that really does not like any change of temperature. So, and this is what's going on. So it's a process of heat shock that's creating this outcome. It's actually quite nice research, and there's some papers we wrote on that in some international journals about a decade ago.
Hmm. I'll track those down and put them in the supplemental resources section. Mm-hmm.
Stuff. It's actually quite interesting, or for me anyway.
Mm-hmm.
So,
Mm-hmm. Just on the different types of hot water service, there's, you mentioned the storage hot water service, but I think it's also worth mentioning the on demand types of hot water. It seems to me that those would even have possibly would be more effective with that a more rapid change in temperature, right?
absolutely, Michelle. That's
Mm-hmm.
a really good point, because the perception when we made this breakthrough was that, oh, the this won't apply to instantaneous or on-demand hot water systems because there's not enough heat applied to it. We actually found the opposite. So, Physics 101, to instantly change a temperature of water from, 10, 20 degrees to 50 or 60 degrees means you're applying 300 degrees heat energy to that water. So it's the heat energy that's suddenly applied that creates this almost instantaneous kill. So what we actually found in field studies, which was the opposite of speculation that this result we found for storage hot water systems wouldn't hold, was from the instantaneous or on-demand hot water systems, is even at lower temperatures, say 55 degrees, they were eliminating almost anything. And it made us think about what was going on. And then we did some lab tests, and it's this heat shock process. if you sort of like the frog in the pond thing that goes around. If you
Oh yeah.
heat something up very slowly,
Mm-hmm.
it either adapts or slowly dies, which is what's
Mm-hmm.
going on here with the storage hot water system. But if you heat something suddenly, you get an instantaneous kill. So, and this is what's happened here. So, instantaneous systems are far better.
Yeah, and both from an energy perspective as well, right? So,
I,
um, mhm,
I'm always banging on about these at home because at home
mhm,
we've still got this old storage clunker, and it's probably the last thing in our house that I want to make sustainable. I want to find a way to sneak that old storage system out the door and put the instantaneous one in
mhm,
because we
mhm,
completely run off solar energy. And I think if we did that, because heating water is actually a big energy use.
mhm,
Instantaneous heating, on demand heating is a very, very low energy use compared to
mhm,
storing hot water. So, yes, please put in your instantaneous hot water system.
mhm. And what do you set your hot water system to, Peter, at home?
For instantaneous, we're recommending
Mhm,
55 degrees C. People are saying for scalding that they need to be less than 50. If you've got young children in your house and you're concerned about that, you can always put a mixing valve in where you've got a mixture of some cold water with the heated water to get the temperature down to the temperature you need.
perfect. Thank you.